Salt. Salt in cubes. Why is salt a cube? Salt is something that comes out of my eyes every time I cry. Also, I consider it one of the backbones of food to give it that savory flavor and bringing out other flavors. So let's learn about salt, specifically the salt that makes food tasty, also known as table salt, also known as sodium chloride, and when using the elemental abbreviation NaCl, it is sort of white and colorless when it is in its purest form and has colored spots when impure, and salt is indeed a cube. Which brings me to my next point. Why is salt really a cube? The quick answer is because salt itself is a cubic crystal. By this I mean sodium and chloride ions arrange themselves in a cube. If you have the attention span for it and would like to understand this more, let's learn about crystal structures. Crystal structure and crystallography. A crystal describes the ordered arrangement of atoms, ions, or molecules in a crystalline material. It is basically the structure of the crystal.
Wow!
And a way to describe the crystal structure is with a unit cell. A unit cell is the smallest repeating unit of a lattice that shows the pattern of the crystal. So what is a lattice? A lattice is a repeating arrangement of points that defies the structure of a crystal, and this lattice is made up of lattice points. These points represent the positions of atoms, ions, or molecules in the crystal structure. And I know that sounds like a lot, so I'm going to go backwards. So lattice points, which represent the position of particles, however, they do not necessarily correspond with these particles. The point is more of a reference point. So there are a bunch of points. Then you have the lattice, and the lattice is made up of these points. Then you can make the unit cell, which then describes the crystal's arrangement. And then that is the crystal structure. If you're still confused, an example might be able to help. So here is a 2D lattice. In fact, there are actually two lattices, one made of black dots and another made of white dots. And the unit cells are the shapes in the lattice. This one here gives one of the unit cells of the black dot lattice. This square can be repeated throughout the entire space, and you're able to find the pattern once I tell you that here's a unit cell, there are black dots at the corner, and that this square repeats. With that, you can draw out the entire lattice. And the same thing for the white dot lattice. We have the lattice points and the pattern of the white dots. You can draw a unit cell, and if you take away the white dots and I just give you the square, you can then redraw the squares everywhere and find out where the white dots are. And it doesn't have to be a square, it could be any shape. In this case, it's a parallelogram, and it repeats everywhere, and still reflects the points of the lattice. Next example, the 3D lattice. Just like the 2D one, there are lattice points, and these points form the lattice. From this lattice, you can make a shape that repeats throughout the entire lattice, which is the unit cell. In this case, the unit cell is a cube. This can be repeated everywhere, and once you know where the lattice points are on the unit cell, you can represent the whole lattice with just the unit cell. If you get anything from this, just know that the unit cells are important in representing the crystal structure. Common lattice systems. There are also other lattice systems and possible unit cells, but for the purpose of this video, I will be focusing on the cubic lattice system and the unit cells associated with it. The cubic lattice system. The cubic lattice system has three possible unit cells. The simple or primitive cubic, which has lattice points at the corners, just like the 3D lattice example. The other two are bodied centered cubic, abbreviated to BCC, which also has the points at the corner, but another point in the center of the cubic structure, and the FCC, the face-centered cubic, which has the corner points as well as another point at each of the faces of the cube. So even though all the cubic unit cells are part of the cubic lattice system, these unit cells have different placements of lattice points where it represents the lattice. Why cube? And what does this have to do with physical shape? Well, it's because the crystal structure is represented by the unit cell and the lattice points, which are heavily related to the physical shape, although this does not always reflect the physical shape due to growth factors, impurities, and various other reasons because real life is never perfect. In the case of NaCl, pure NaCl has a crystal cubic structure and in turn a cubic appearance. The salt unit cell. Here we have the salt unit cell with the sodium ions being purple and the chloride ions being red. This unit cell has the FCC, the face-centered cubic unit cell, and has 6 points at the corners as well as another point at the face. Now, you might not be able to directly see it from this image, but if you do what I like to call productive staring, you might be able to repeat this shape in your head to create an even bigger cube. And if you're still not able to see this, don't worry, that's what the next slide is for. Here is the crystal structure of salt. It is basically this unit cell but repeated a bunch of times. The chloride ions are the green and the sodium ions are the purple. And I will be assigning a lattice point per pair. So one of these pairs I'll be assigning a lattice point. I'll put a lattice point right here, 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 and then for this one, right here, here, I'll be putting more lattice points at the top as well. And then I'll be drawing a face of the square, or of the cube, I mean. So here we have a face, we have the lattice points at the corners, and a lattice point in the middle. Same down here. So this is indeed an FCC. In conclusion, why is salt a cube? It's because the shape of something is heavily related to the crystal structure. The crystal structure is defined by the unit cell, lattice, and lattice points. In this case, salt has a cubic lattice, specifically an FCC, so the square packing of the ions is what makes salt a cube. Basically, salt is a bunch of tiny cubes that are made up of ions, and therefore giving it a cube appearance. As a reminder, I'm a Vtuber and a failed engineer. I call myself a failed engineer for a reason. I'm still learning a lot of things myself, so I could be wrong on some stuff. I try my best to get it all right, but studying and researching on the topic can help with your understanding too. Thank you for watching. Thank you for learning about why salt is a cube with me. Like, comment, subscribe if you like to. Beep boop. Bye!